Do you want to know how to do this? We're going to take a messy jumbled list of 65 students from the Motivated Strategies for Learning survey and transform it into a full statistical report. Whether you are a teacher trying to understand your classroom or a student working on a research project, I'm going to show you the manual formulas and the actual shortcuts for everything from the mean to the standard deviation. Let's dive in. Starting with a dataset of 65 students' scores from the Motivated Strategies for Learning surveys. Right now it's a bit jumbled up. To make it manageable, let's copy this data to a new column. Right click and select sort smallest to largest, much better. Now let's build a frequency table to simplify our calculation. We need two columns, x for the score and f for the frequency. And then create x times f, and then x minus mean, and x minus mean squared, and then f times x minus mean squared. To get our unique scores, copy the sorted list into the x column. Before counting the scores, we need to remove the duplicate first. So we go to data and then click the column and then remove the duplicates. Time to count how often each score appears. We'll use the COUNTIF formula. Type equal COUNTIF, select our original data range, then select the first score in our table. Drag that formula down to fill the rest. As you can see, we have 12 number of 132, and we can count it up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To double check our work, we'll use the sum function on the frequency column. It should equal 65. Perfect. Next, we need the product of our scores and their frequency. We select our scores and multiplied it by the frequency. There we go, and then just drag it down. And after that, we can drag the sum to the right. Okay, moving on to the next column, x minus mean. However, we haven't found our mean yet, so we could go create the mean. Mean equals the sum of x times f divided by the sum of f. Simply select the sum of our x times f and then divide it by the sum of f. There we go, we have found the mean. It's 136. Of course, if you're in a hurry, you can skip the table entirely. Just type equal average and select your original raw data. Both methods give you the exact same result. Now that we have our average, we can calculate the deviation for each score. In the next column, select your first score and subtract the mean value we just calculated. Easy, right? But what happens when we try to drag this formula down? You might be confused why the numbers look wrong. To fix this, we need to lock the mean cell in our formula. Go back to your first calculation and put a $sign before the column letter and the row number. Now when you drag it down, Excel keeps its eyes locked on the mean while it moves to the scores. Problem solved. Moving on to the next column, we need to calculate x subtract by mean squared. Since some of our deviations are negative, squaring them ensures all our values are positive. In Excel, this is simple. Select your first x mean result, type the caret symbol, and then the number 2. As usual, we drag it down. I feel like we're missing something. Yes, the median and the mode. These are essential for understanding the typical score in our dataset. First, let's find the median. This is the exact middle value when all 65 scores are lined up. We divide the total frequency by 2, that gives us 32.5. We can't literally find a half position in a list, but this tells us our median is stuck right between the 32nd and 33rd numbers. The number 137 here represents the typical motivation level for this specific group of 65 students. In Excel, just type equals median and click the column where the original dataset is. Next is the mode, which is the score to appear most often. If you remember our frequency table from earlier, we saw that 132 had the highest frequency. To confirm this with a formula, type mode, we can pick mult or single. Here we just put single because there is only one number that is frequent. This highlights the most common motivated strategy score among you students. Finally, we have reached the last column of our table. We take the frequency of each cause and multiplied it by the squared deviation we just calculated in the previous column. Once you drag that formula down to the bottom, use the sum function one last time on these values. This total represents the sum of squares, which is the heart of our statistical analysis. After finding the heart of our statistical analysis, let's move on to the measures of variability. This tells us how spread out our student scores actually are. First and foremost, we can calculate the range. To do this, we take our highest score and subtract our lowest score. Before we jump into the variances, we need to look at the interquartile range. This is great for seeing where the middle 50% of our students fall. Manually, we divide our sorted data into 4 equal parts using 3 markers: the first quartile, the second quartile, or the median and the third quartile. To find the position of Q1, we use the formula 1/4 times number plus 1. Since our number is 65, we are looking for the 16.5 position in our list. In Excel, we can skip the manual counting. Just type quartile inc, select your data, and type 1 for the first quartile or 3 for the third. For Q3, we look for the 3/4 mark, which would be the 49.5 position. To get the interquartile range, simply subtract Q1 from Q3. This tells us the spread of the middle half of the class, ignoring any extreme outliers at the very top or bottom. Since our data is not different from the Excel formula, we can drag it to the right. Now that we know how the middle of the pack is performing, we can finally head back to the heart of our table to finish the variance and standard deviation. Now, for the moment of truth, the variance. To find this, we take the grand total from our very last column, the sum of f(x) mean squared, and divide it by the total frequency. Since our sample is a people, instead of just dividing by our total number of 65, we divide by n minus 1. So, 65 minus 1. Now, if you want to save yourself the manual division, Excel has a shortcut for this too. You can just use the formula equal var s, just select your original raw data range, and Excel will automatically handle that n minus 1 for you. Notice how the result matches the manual work we did with our table? It's a great way to verify your math. To get our standard deviation manually, we take our variance and find the square root. You can think of it as taking our variance to the power of half. Or, if you prefer names over numbers, just use equal sqrt and select your variance. Both will give you the exact same result, the standard deviation of our students' motivated strategies. Finally, let's create a polygon chart to see the overall shape of our data. Start by selecting your scores and your frequency columns from the table we built. Now in the Insert tab, we can see recommended charts. We usually pick Scatter for this. And there you have it. This polygon gives us a clear mountain view of our classroom. We can see our peak at 132 and how the rest of the 65 student scores trail off. And that brings us at the end of our data analysis. We have successfully taken a jumbled set of 65 student scores and broken them down into meaningful measures of central tendency and variability. I hope this tutorial helps you with your own data projects. My name is Ghazia Zidane Octavarian from Class C. Thanks for watching and see you later.